This video is sponsored by QuickNode. Hello and welcome to another Solana tutorial. Today we're gonna have a look at QuickNode functions and their key value store. I have never worked with this. I don't really know what it is, but the guys from QuickNode were like, that's a cool thing, you should check it out and make a video about it. And I'm like, okay, let's do that then. And I had a quick look at the docs, and it seems to me like it's a kind of a custom API call that you can build. But in order to really understand, let's have a look at QuickNode functions. QuickNode. Oof. Hello, brightness. Serverless edge functions for blockchain data. Yes, I want that, even though I don't know if I actually want that. Okay, I need a QuickNode account for this. Okay, fine. I'm not a robot. Why is this taking so long? Okay, I have a QuickNode account. So, functions. Deploy your actually, before we do anything, should we look at docs maybe? There must be some docs for this. There we go. This is bright again. You don't happen to have a dark mode, do you? How about Solana? Yes, QuickNode supports several chains. They're not as Solana heavy as I am, but they do support Solana, so that's fine. But also, I'm not using QuickNode as my only RPC provider, so it's just fine. It's fair. This no, I want function. Here we go. Look, functions. There are products. We've got stream, we've got functions. Let's get started with functions. Functions enable you to quickly build, deploy, and use serverless functions without the need to manage infrastructure. Oh, that's nice. So basically, it's all done on QuickNode servers, and you don't need to host anything yourself. Your functions can be used as destinations for streams and can also be active via API. What all of that means, we will have to have a look at that. API ready. Your functions are automatically exposed as an API, basically meaning that we can query it like a regular RPC call, you know, like the RPC get balance is a function call of the RPC. QuickNode being our RPC, we can call get balance on the QuickNode RPC URL, but we can have our custom function, which does something more than get balance or something different, you know? So we basically just expose an API. Performance at scale, blockchain optimized, storage access, cost effective. Well, I mean, you get the ideas. I'm not going to go through all of that. Billing, I don't really care. But you might want to look at that if you actually deploy something in production, because it might get costly. I have no idea, but you do the math. I want to just figure out what it is and how to use it. We can use it in 3 ways. With the test activations from the developer portal, or that's what we're going to do first. Stream activation. So a stream is those things. Is a data streaming solution designed for Web3 applications. Basically, we retrieve real-time and historical blockchain data, and we can stream it directly to the function instead of, somewhere else to process it. So that's the second possibility, how the functions can be activated. And what we're going to start with, or what we in our first example is going to use, is just an API activation. So we call a certain URL, and then the function is invoked and should return us what we want. We get an API endpoint just for a function. Supported chains. Solana is supported for mainnet and both dev and testnet. Nice, that's all I care about. And then it already gets to function configuration and the function editor. We're just gonna have a look at this live. I'm gonna switch from black to white. I don't like it. Maybe I should just go light for the entire video. I mean, it's not as heavy if I switch from here to here. Yeah, let's go white. Why not? Okay, let's deploy our own function and look at the things as we encounter them. We can use this in the free plan. That's nice. We have 250 gigabyte seconds to use for free. No idea how much we will use, but let's try. Okay, so if we deploy our function, we need to give it a name. And this first function. And we can select which runtime. So basically, this is... Oh, I can only select Node? Well, we can only select Node for now. But I guess there is or they want to support others, or maybe that's not in my free plan. I don't know. It looks like there is possibility to use other languages, but I want to use Node anyway, since it's the one that I'm most comfortable with when it comes to writing Solana stuff. I know that's what we're used to from the Web3.js. And a description, blah, blah, about your function goes here. Okay, and now we get to this function editor, which is basically already providing me my function, essentially. It's like an online editor where I basically provide my code. The function is called in such a main function. So I think it needs to be called main. So the main is invoked when your function is called, and it gets params, and the params contain data, may contain data, and metadata and user data. So that's what we're getting out here. And then we can say this is the data from data set we get from the metadata data set. So that's, for instance, in this case, Ethereum. But do we want Ethereum? No, we want Solana. Yeah, Solana mainnet data. That sounds right. And the user data, if there is any user data, and it should return a message that will be logged and returned when a function is called. We can even chain functions by calling them inside each other. Wow, okay, nice. So the return, basically here we return this as a message and we return the user data and the parameters right back. So basically the function does nothing except for return what it got. And then here would be in comments a webhook example where we could call our custom webhook. So the function would then again do a webhook and whatever it gets back. We don't really need to worry about that. We don't want to do webhooks for now. So the simplest function just gets the metadata, the user data, and then it would directly return this. And we could, instead of returning, call a webhook. But let's stay simple in this first example. This is our function and we can save and test. Oh yeah, that's the first way how to call it. Here in this test activation. There we go, we get something, 480 milliseconds. And the result we get is in this format, you know, here. This is data from the block dataset on the Solana mainnet network. So we selected Solana mainnet and that's block data. We got the block time, the block height, the block hash. Ooh, we're close to 300 billion. Slot height is already over 300. Previous block hash. And then in here, even the entire list of transactions of this block with all of the account info, accounts, signature, version, and program logs. So quite extensive data actually that we're getting here. But this is just for one block, right? All of this, lot of data is just one block. Here ends the block. And then we have metadata. Dataset is block and network is Solana mainnet. That's also then the metadata that we had here in this params thingy. I would like to see also the user data. Is that in here as well? In the params, we have the message and the params ends with metadata. So we don't have any user data, I guess, in this example. Oh, because we don't have any user data. We didn't provide anything. We can pass in custom user data here if you want to make your function specific to a user. So next thing we should discuss probably here is this data set, because we have two options. We have block, that's what we got now, and we have program with logs. How about I just try program with logs and see what's different? Different is the metadata now telling us program with logs. Still on Solana mainnet, and it will also change the message. This is the program with logs dataset. And here we get the data. So in params we have data with a list of signature, slot, block time, program invocations. Aha. So I think that's even more granular per transaction what other programs it's actually calling. Then we have the next transaction, slot and block. So here we got a lot of vote transactions actually. Another vote, let's scroll somewhere in the middle. There we go, that's probably another vote because that has token program. What is this? Signature, there we go. So program invocations, we invoke the associate token program with those accounts. So it lists data, even parsed. Tells us what instruction was called. That's also parsed. And then it tells us token balance changes, or token balances at least for this account. Then the tube program was invoked. And within the tube program, let's see if we get that granular detail as well. Here we have several accounts being involved. USDC, this one is USDC for the kitchen. And this one is Sol, another mint. And that's the logs. Okay, so we don't get the inner instructions. We didn't see this one, so we don't see the inner instructions. Okay, so that's programs with logs. We do get the logs of the program if that's relevant. Did we? I don't think we got the logs in the previous one, did we? And here I'm basically just channeling through the function what we get in to what we get out. But obviously we can now work on this data set, work on those parameters and do stuff with it actually. And if we do block again, We get transactions with account keys and stuff. But yeah, we do get log messages though. We even get inner instructions. What's the difference? Look at the docs. What's the difference? So for Solana, the dataset scheme, we've got block or program logs. Block or program logs, that's the two things. Other chains have other more granular things, but for Solana it's block or logs. The block datasets includes data from individual blocks on Solana, who would have thought, such as block head, block time, etc. And detailed transaction information. So that also has detailed transaction information. This schema allows for real-time and historical block monitoring. It is suitable for use cases that require in-depth block and transaction analysis. Block and transaction analysis. The spec for that, that's what that's transactions is an array of transactions included in the block. Yeah, okay. This transaction even includes stuff like account balances. Quite extensive what we get here. That's cool. And logs, dataset captures detailed program invocations, log messages, and associated transaction metadata. Reports use cases requiring a deep dive into program interactions and program logs on Solana. The signatures, log, slot, block time, details of each program being invoked. Okay, so not 100% sure yet what the real major difference is, why we want to use this or that. I guess I just gotta work with it and see. One thing that I can read is that this one supports historic monitoring. So if we want to analyze old blocks, I think we gotta go with this. Not 100% clear what the difference is. I'll figure it out. But let's go back here. This is what I'm used to if I, query info from a transaction with an RPC, like getting the transaction for a signature, for instance, or subscribing to a block, like a block subscribe will give me something similar, if not exactly this stuff. So that's the block data set. For now, let's just work with this and see how we can actually call our function, because this is just testing now. I want to see, because I saved my function, right? I save and close again. And then here in Andy's first function, I get a trigger URL, api.quicknode.com/functions. I copy that URL, and then I will also need an API key. Otherwise, we have API key missing. So, and we have insights currently at 32 megabytes, and we have 250 gigabytes, right? So first I need to generate an API key. Cool. Copy that. And then when I want to actually call the function, I need to put in the API key as X API key. So that's in the header. Okay, so I can't easily do it with a browser, but I can use CURL. So I could do this, except instead of this function, we call our function. I don't know what result only does, but I'll keep it. We keep that, and here we need to put in our key. And I'm just gonna show you because here, this is mine. Because otherwise I'll have a hard time not showing this. I'm gonna revoke it later anyway. And then here's the details that we earlier gave through this. Oh, it's not here anymore. How do I get there again? Edit function maybe? Yeah, in this editor here, when I set the data set, here I can add user data or data set. And this is just added as data in this JSON format. We have user data, and the network shall be Solana mainnet, and we want block data. Yeah, well, we'll leave that out because my dataset doesn't understand it, I think. Maybe it does. Can I do 299? Can I get that block? And user data, it's not using that yet, but I could be like, whatever. My function could do something with that then. And like this, I could actually, call our function. Let's see if that returns. Yes, it does. And it gives us all that we had before in a bunch of text. And we see already here, it also gives me back my user data. It's me. I called it. And the metadata here, dataset block. So it seemed to have worked that we get the block information for this specific block. That's in slot 321. No, maybe it ignored that. Probably it ignored that. And actually, I'm not even that interested in all of that data. So let's change our function. I'm not interested in all of the parameters. I could be like return data. Let's say it's the same as params, but I'm just interested in that stuff. I'm just going to remove the transactions. Let's do this just temporarily. And if I save this and I call the same thing, Nope, that didn't work. Because obviously I still have the params here, not my return data. Oops. Nah, not save. Save like this. It's a bit annoying that it always... I cannot just save. I need to save and test or save and close. I can't do just save. Okay, whatever. But I could, you know, save and test. Oh, I still get transactions? Why do I still get transactions? Data. Oh, data is a list. It does take longer on Solana. In Ethereum, we're done in 10 milliseconds. Well, there's a difference between those two blockchains, isn't there? There we go. Now on Solana, we still have data. Oh yeah, because it could... I understand. Because it could have several blocks that it's providing for us. Per default, it will just give me one block, which is the current block, but it could be more. So if I just want to strip that out, and there are examples, I saw that here, learn more at functions library. There are code examples out there that we can have a look at. Could stream to Discord, fetch Solana NFTs or SPL tokens. You know what, let's just look at this wallet portfolio. It's a bit more complicated because it already used the key value store, but it also has such a main, and then it does stuff. Hold on. Aha, see, this is what it's doing. It's getting the data 0, which is the transactions for the first block, I guess. And then for each transaction, it does some stuff. You know what? Since we just get one block, let's just get the first block and then say transactions. So we delete basically the data that we would get here because I'm not interested in that for now. Let's see what we would get back then. There we go. That's what I want to have. Something nice and compact. Just the metadata of the block like this, block hash, and the transactions are omitted. It's not actually that there are no transactions, it's just omitted because my function says, well, we don't need that. Why would we push it to the client who is completely overwhelmed by it if we don't need it? And now, if I call this, there we go. This is way more compact, still not nice to read, but we get our nice return data with just the block info. Kite block time. And no, it doesn't take that block number because it ignores that. My function would need to do something with it. Same as with the user data. My function would need to do something with it such that it has an effect. I mean, we return it here. That's all my function does with it. And instead of calling this with curl, I'm gonna build myself a script such that I can then also format it nicely and, you know, use it properly. Let's get Axios, call function like this. There we go, out of the box. It even neatly formats it for me. So I have a function to call my QuickNode function, which basically does the same thing as my curl. We put those 3 headers with my API key that I have up here now and will log me my response. So my response is then this. Nice. The data is an object. And now here we can, you know, work with that data. Like, actually, maybe we want to return the data. And then here in the response, I can be like, and this way I could also... What? I have no data in response? No. What? Oh, this is also in return data. Then we should have some data in response. Yeah, there we go. And now here we just have the data in the return data in the response with that information that we get from our function, where we omit all of the transactions because that's what our function does. So let's change this. Let's make our function actually do something, you know, productive with those transactions. Let's, for instance, say we're interested in all transactions from a block that do a system program transfer. How about we're interested in all sol transfers? How about that? Let's go back to our function editor. And instead of, you know, deleting all the transactions in that block, let's say this is my block. And per default, we just get one block in the data here anyway. There is another way how to call it with like more blocks. Probably when we analyze like old data. I guess we would need streams for that. Because yeah, per default, it always takes 0. But that's actually maybe already a good tutorial for this vote analysis for each transaction. Oh no, this is working on the program logs where it gets the transaction directly. We are still working on the block metrics. So this is how we would do it. Here we would get the block like this, and then the transactions of the block, here we would do a for each. Something like that we can do. You know what, I'm gonna borrow this code. This is actually a great example. I'm gonna borrow this entire example. And I'm gonna put it here. So basically we create a temporary object called metrics where we even put the message. Okay, so then don't need to put it here, you know, the message and the user data, then it's all in metrics and we return metrics. Cool. We copy from the block time and block height. And then we create a few variables for what we want to analyze, the compute units, the average compute units, total fees, etc., etc. Success transaction count, failed transaction count, accounts and unique signers. Wow. Yeah, and then we go through all of the transactions. For each of the transactions, we add to the compute units and the fees, you know, to our temporary variables. We add those. We're here on the transaction level, and in the meta, it has an error. Okay, so we can say if there is no error, then it was a successful transaction. So we do get the information whether or not the transaction failed or succeeded by checking the meta error field. Good. And then we can check balance changes, post balance. Is this all sol? Probably all sol. No? And we get the invocations from the log messages. Really, from the log messages you want to get those? I mean, okay, fine. Literally goes through all of the log messages. I mean, not an efficient implementation, or like, I mean, I don't know if you want to go through log messages, but whatever. I mean, the example does it like that. Let's continue like this. And we basically just split. We're looking at top level instructions. So invoke 0 is the actual instructions, the high level like the instructions in the transaction directly. CPI depth 0 or 1, whatever. So no CPI, level 1. Then we split because it says program invoke. So if we get the first one, rid of the program, and then we just get the actual program. I mean, it's a bit ugly, personal. It will work. It will work if we get the logs and, you know, okay, fine. And then we can check account activity. For all of the account keys, we again do a for each. If it's a signer, we add it to the signers. And if it's writable, we add it to the writable accounts. Wow. I mean, it does quite a lot. And then we can, you know, calculate the metrics with the averages and convert the sets to counts, and then remove the sets, and then we return those metrics. I mean, let's test this here, and that would already work. Pretty nice. And also in here, let's just get the entire response. And then we can look at the successful transactions versus failed transactions, total writable accounts per transaction. I mean, yeah, if you want those stats, you know, you can compute whatever you want. You have all the block information that you can access, and then you can return stuff like that. There we go. Also works if I call it with my script. I call it for a different block though. This is the block, the 422. And for both blocks, the program that's most often called is the vote program. Also here was the vote program, then compute budget, and then already Jupe for this one. Oh wait, is that sorted? No, this one is not sorted. But it seems sorted because this one was the first one that was added. And yeah, the more often it's called, the higher the likelihood that it's added first. So that makes sense. So it's pseudo sorted. I can of course sort it. I mean, I'm running code here anyway. What if I wanted to sort that? The program invocations. Before return, this will be ugly, but it will work. We make an object again from entries, and we have a sort function where we specify the difference. So we always compare the value and not the key. We compare those and not this. That should hopefully sort it. Save and test. And there we go. Now we actually have it sorted as well. So our functions can do that. And this stuff runs somewhere on QuickNode infrastructure. So you don't need to worry about, you know, hosting a server to run that code. You can just do it from whatever, you know, front end. Here I'm doing it with my Node script, but this could be, you know, a web page, some user front end, some browser calling this URL directly, as it would with an RPC. But it can do more things than a regular RPC because you can define what it does. That's a function by QuickNode. That's pretty cool. We can call that function, and then we get the info that we want. See vote program, then compute budget, then system program. Ah, I see why it does that. When it starts with a number, then it needs to put it in upper quotes. Still a bit weird. So that works. I actually don't like getting this from logs. Transactions, we have the meta, then the transaction. Here we get the actual account key, so that's the account infos, and then we get the actual instructions. I'd much rather get it from instructions, no? Why not from instructions? Why don't we get it from instructions? So if I were to implement it, instead of this here, transaction dot message instructions, and then for each the program ID. And I should probably have, you know, question marks here everywhere. Instruction, program ID. I'm gonna make a second one, my program invocations. Backup, I don't know. I want to do both at the same time because I want to prove that it does the same thing, and I'm getting different blocks every time, so I need to do it in one. And I guess that will do the same thing. So I'm now getting the information from the instructions and not from the program logs, which I find a bit weird, honestly. So save and test this. Let's see. Again, vote compute system program with 234. And in my backup, I should have the same data, except I get more calls to the system program. Maybe here I'm counting if one transaction has several calls to the system program, I count it several times. We can see that this number is the same because a vote instruction is always just the one instruction in that transaction. That's why this number is the same. Is that true? So if the log includes an invoke, then we split it, but that should still count more per transaction, no? Oh, wait. I think the difference here is at failed transactions. At failed transactions, they are not all in the log because it can fail and then it's not in the log in the rest. But for the entire instruction, it is in there. So what we should actually do is only do this entire analysis for both of that for succeeding transactions and not for failing transactions. And if we do that, then probably we get the same results. I'm playing around with this. I like it. It's interesting. So now we have 1155 and 225 for the system program. And here 1155 and 225 for a system program. There we go. So it is the same, but not really because, different things. But you need to know what you want. Here is the actual invocations. Here's the what is in the transactions. And then here, both of that with that thing is only what is actually being executed. Only if it's actually being executed, then we count towards our program invocations. Yeah, fun. So these functions are actually fun. Yeah, you can build cool stuff because you can code whatever you want in here. And let's go back to I want to know all of the transfers or something. I want to know when the system program does a transfer from one account to another account. This I can't do with the log anymore because I can't find that in the log. I can find that the system program is being invoked, but then I don't get what instruction is called on a system program and which accounts. That's not in the logs. So there I want to analyze this. So what do we actually want to store? Let's store, and let's actually start this out as a list. We'll make modifications in a second. For now, let's just save whenever it's the system program. If program is the system program, like this, because string compare, that's safe, right? We should probably do something with equals, but yeah, whatever. TypeScript is totally safe. Then in my metrics system program invocations, I'll push the entire instruction just to see what's in there. There we go. We get the same as before with our program invocations. We have a bunch in here, 900 system program invocation. And the actual system program invocations have the following info. So one of them looks like this. It has program system. So that's already like a parsed stuff. That's the program ID. And it has parsed info for destination Lampert's source with type transfer. So we get it in a parsed format here anyway. We can just use this. So we can just in the parsed get the type and check that it's a transfer. Most of the system program calls are transfers. Here's one advanced nonce. So yeah, we get parsed information. That's sweet. We don't need to do that manually ourselves. So we can work with that. Let's say if we have a instruction parsed type transfer. And now we need to think of, well, what are we interested in? Are we interested in who is sending the sol? Are we interested in who is receiving the sol? Both. Let's do both. Sure. Okay. So sol senders. We're gonna do an object again. And then sol receivers. And this is just with the system program. You can also send and receive sol through, other means, but this is just for system program transfers. And we're gonna do a similar thing like we did here for each program where we count we will be like metrics sol senders for source, receiver, destination, Lamperts. And then we say sol senders for the sender shall be 0, or otherwise we add Lamperts. And the same for the receiver. Sol receivers, receiver. There we go. And this way we log for every sender and for every receiver how much they receive. And then, since we already know how that's done, you know where we sort it. I should really do a function for that. Function that gets the object entries from the object with this sort. And one more time for the senders. I always hit Control S, but no, here is how I save. Let's see if that will do. I mean, it looks good. Look what we're getting here. We get the receivers. I mean, I don't know any of those. I mean, this could be, you know, anything, but sounds plausible to me. And the senders, this guy is well funded, no? Let's check for another block. Probably get other values. But yeah, that also seems to work. There's another. I'm not going to go through and verify this, but I'm just going to expect that that's working. Wow. Hold on. That's 32 sol were sent here. And look at that account. It now has 32 sol. So that seems to work. Seems to work just fine, my nice little function here. And you know, I can calculate whatever metrics or whatever I want. But that's just step 1, right? This is just when we use functions as an API. Hold on, why did we see this? When we use the functions as an API, that's what we did so far. What's even cooler is if we were to do that with streams. And before we do that, we need to have a look at the key value store, because that's the way for our functions to keep state. That enables you to manage extensive lists of data points, such as hundreds or millions of wallet addresses. And again, we don't need to worry about the infrastructure. QuickNode does. So we can save wallets, we can save historical data, we can do data analysis. So we have those possibilities for lists, and there is sets. So we have either lists or sets. Sets is for key value. So basically a map, right? I would call it a map, because a set is just the keys. Using key value store with functions. Oh, wonderful. That's what we want. Basically have the exact same. No, we need to say QuickNode library get that. Okay. Function main must be async if you're accessing key value store. Okay, so let's get our thing some state. For that, we need to make this async, he said. And for now, let's just forget about all of that metrics stuff. Let's do a quick function that basically just saves how often the function was called, just to prove that we have state. So what we need to do is have some kind of variable. So I just need a set with one entry. How would I do that? Delete set, add set. You know what? In my return data, I'm just gonna put the... So I'm expecting something like this set doesn't exist, kind of an error, null. Okay, this gets me null. Fair enough. So if set result, oh, actually, let's just say if not set result, then we need to say edit, add set, and I'm gonna make a variable for this. I'll put it here so you can see it, because I don't like copying text like this. Add set, and then I put, what is this? This is already a value. I'm gonna put this like so. Add this to my return data, and then I'll test this. Invalid argument type. Oh, that's the first time that we get an error. What is the problem? Maybe this thing. Argument assignment to constant variable. Wait, what does this add need? It sets. So the set is in that sense not a map. It is literally one key value pair. So like a tuple. I still don't get what you are complaining about here. Is there an example? Solana wallet portfolio. That also uses there, but it uses lists. Maybe I just need to delete and then create again. Who knows? I don't know why I need those parameters here, but I'll just parse them in. Then I'll create it again. What happens now? Ah, it doesn't like this thing. Yeah, sorry, my bad. This is, that's what you get for not having a proper IDE that doesn't tell you that this is const. So, okay, back to where we were. We don't delete, but we create again. The delete was okay. Create is also okay. And if I create again, even though, because that was the first, and then, okay, and then the second one, it has the value, and then the create is again okay. Okay, good. So we can read and we can write. Wonderful. Finally. So let's call this invocations. So that's the previous number of invocations. Number of invocations is this, or 0 plus 1. And then we store in the return data the number of invocations, and also store the number of invocations here. And this is at the first time gonna fail because I'll once need to delete it for that to work, because now I still had a string in there. But then I don't need to delete this anymore. Okay, now it should work. And the create will always give me okay, so I'm gonna save myself this. And now I should be able to count up the numbers, number of invocations. Oh, nope, it's treating it as a string. It's treating it as a string. Okay, welcome to TypeScript, where you need to be explicit with your freaking types. Okay, so this is a string, and +1 just adds a string. How can I make this a number? There was a trick to this. How did it go? Wait, I need to say plus. Do we get 111 and 112 now? Now we get a number. Wonderful. I mean, with the 112, we cheated us to 112, but like this, click 14, click 15. So we do have state. We can save stuff into this set, which is basically just a key value pair, which I don't call a set. The entire thing is the set. Honestly, the naming could be better, so I'm not so confused when I try working with this. But yeah, it's just one key value pair. Wait, but could that set actually be a set though? Could I be like, the value is an object? Apparently, no, I cannot have a set here. We tried this in the very beginning. It doesn't work. Okay, fine. It doesn't work with sets. We've figured that out, and we're back to 1. Point is, we have possibilities to store values for a given key. I should probably call it key. It doesn't matter. They call it set, which is confusing to me. Doesn't matter. Okay, so we can persist stuff, which brings us to the last interesting thing that we can do with our functions, calling them via streams. So for that, we need to analyze what streams are. God damn it, this is a long video. With streams, we can access a variety of data sets tailored for different types of blockchain data. So basically, what we did now is, we call our function once, and at that point in time, it executes the thing and gives me the current block, basically. But what if I wanted something like, if a certain event happens, then I want my key value store to update. And we can do that with streams. So whenever an interesting event comes, we can call our function that it does some update, and then we get the info. Let's try it out. Let's create ourselves a stream. We do it for Solana, of course, mainnet. Our stream will start at the latest block. Yeah, I think that's what we want. We could analyze some historical data and already do some filtering on that. But we will start at the current block, that's fine. We could also stop at the specific block to just analyze some historical data. Oh, that's cool. We can also have a delay, but no, we want it as soon as it's available. Yeah, let's see, let's go next. We go with the block data set again. This data will be streamed. Customize the payload to include data you want. So this is what we get. We're used to this, We can modify the payload before streaming. We can have a function that does that. Logic to filter data. This stream could then also use the same lists or sets. Then I don't even need to send the result to a webhook. I can just set it up with my function. I mean, I can let the stream hit my function every time, which is gonna be a lot. I would probably prefer to put a filter and then store stuff in the same key value store with this thing that I can then access in my function as well, I think. I can select an existing function as my destination. And this is how I could stream data or historical data into my function, the function could then store it in the key value store somehow, and then I could fetch it with the key value store. Something like that could also work. Hold on, let's see. Let's invoke this one more time here. Then we are at 115. We send the payload, stream test successful, and if we now call it again, we are at 17 because once it was invoked with the stream. That's cool. And the stream will, give it that data. If it doesn't come from the stream, it just gets the newest block. But with a stream, we can define and pre-filter what should get in the function. And then the function could, itself do calculations on the data and call a webhook or store stuff in the key value store, which we can then receive like this. What could I do? I could find out whenever somebody transfers to my account and list who transferred to my account, or the other way around. I find an account and I see where it transfers to or something. We would like to create a function that tells us which wallet sent us some sol. How about that? That's a good use case. This is what we're going to build now. We are processing all the transactions. All I'm interested in is, like I had here, on success. So when there's no error, then I check the instructions, see if it's the system program, see if it's a transfer. And then I'll do if my receiver is... And here, probably you want to store something in the key value store if you wanted to support several, or if you want to dynamically change it. For now, I'll put it in hard-coded. So I need a wallet that starts with Andy C. Oh, you find the better one? Receive X amount. How about that? Andy's receiver. If my receiver is this guy, then I'm gonna somehow log it, and this time I'll store that in the key value store. And for that, I'm gonna use a list because I'm just gonna store the sender. I could do with a set, but that would make it more complicated. With a list, I can just use one list and put all of the addresses in there, if I'm just interested in the addresses. If I wanted to store Lamperts as well, I would probably do it with a separate set. It doesn't really tell me that I need to first create a list before I can add an item. I'm just gonna try that. Should we just try lists first? So here I will have my list, and I'm again gonna do a const for this, something like that. List name, and the item that I'm adding is the sender. And to test this, I'm gonna remove that check real quick and just add it anyway. Add all of the senders. Let's see if that works. At the end, I will get my full list. I will await a get list, and then I will add the full list to my return data. And let's see if that would do what I would expect. So maybe I've deleted this and this and this. Okay, and now? Yep. Oh, wait. I'm doing an await in a for each that is... Okay. Maybe I can't do that. Well, then let's not do that in here and just store them temporarily in const senders list. And here I just senders push sender afterwards. Can I add several at the same time? It's probably with this upper cert. List items added, my list, and add items. I don't want to remove items, just gonna add items, and the items I add are my senders. There we go. That should add me several. Also put that in the return data such that I see if that was okay. Then I get the full list right after, just for testing. Let's see if that would work. Cannot read property of undefined. Oh, hold on. Expecting a Solana mainnet block and not an Ethereum, whatever. Even that. So I guess this is my issue now, right? I mean, ideally I would do something like return data for each block, do the following. And then all of that stuff that needs the block goes in here. So within a block, we process each transaction. Then I don't need this. But then still I'll have the issue that I won't have anything. It looks like I'm not getting any block. Oh, I'm doing return data? How did I get here? Oh, because I set it in the parameter. Oh, hold on. This is some copy paste errors. forget that. It should be in the params data, of course. Params data has the data set. Yeah, that makes sense. But anyway, now we fix that to also support more blocks. Forget about that. And now that should work again, hopefully. There we go. We're getting something. Number of invocation is 124. Wow, it was invoked more times, or maybe I've... Yeah, it also does it when it fail. Apparently, it also writes. So it's not like a Solana transaction where it reverts the key value store. No, once it's called, even if it then later fails, this is still increased, I guess. So the values are still written. And the list items added, okay. Sweet, so that works. It creates the list at the same time when it adds, and my full list is that. So those are now all the addresses that sent some sol somewhere in this one block. And if I would run it again, I would have the same addresses in there plus a few more from the other block, the next one that we just analyzed now. So that should work. That's cool. Actually, I already like this, that I then read the full list, because the full list is what I want to return. Maybe I'll call it all senders, and then my return data will have an all senders. And I'm not gonna add this. Good. So that will work. Now we just gotta get that back and only push senders that actually have this receiver. And maybe I should once do a delete list. And I could now either put it in and then remove it again, or I would make it dependent on my parameters, like on my user data, something like admin. Then I would delete my list, and for the fun of it, also the set. That's how we would reset. And so to do that, I would add some user data here that comes in JSON format, and I will give it the admin, which is true. I mean, anybody can write anything here, right? But reset all is also true. Now send it with this payload. There we go. That's the user data that it repeats back to us. But that did not do this thing. Maybe if I put it a string, true. You just need to know how that's done, right? Or I say yes. Reset all, yes. You need to type yes. You need to know this, just so a hacker can't easily just reset all if they don't have my source code. Anyway, this way. Yeah, now it worked. Cool. Now this one also. And then I actually deleted my list and my set. So now my number of invocations is down to 1 again. And all of my senders are back to an empty list, because we had no sender to our specific receiver in that one block. That works, so I can leave that in there. Perfect, but I'll remove this for testing. And now we can, send sol to this guy and hope to get the exact same block or something. I'm gonna send to here, and then I'm gonna say 3, 2, 1, send, and save and test at the same time, because I need to get... What? Oh, the user data is undefined if I don't put user data. See, that didn't work. That didn't work at all. Should have tested this before. There we go. Number of invocations, still no senders. Did I send though? Okay, let's do it again. Send some sol to this address, 0.001. Let's go. Send and test. Oh, it wasn't the exact block where that transaction went through. Damn it. So yeah, this only works if I hit it exactly at the time if I get the exact block where that transaction lands, and seeing that blocks are less than half a second, this is gonna, not work. Just not work. But that's why we have those streams, right? So let's step back here and start out again with Andy's first stream, damn it, for Solana mainnet. And this time we use historic data. And when you say specific block, you probably mean slot, right? In Solana context, we're talking about slot here, because this is the current slot. I guess the 662, that's the current slot. So I'll just do 000 here. So the previous 500 slots should be enough. I could go further back in time, but that's what we're gonna do. And how about for now, I also stop at a specific block, the current one. Yes, so I just analyze historic data. I go next. Because my function is smart enough to batch, I will send... How much can I fit in one? I mean, let's check the infrastructure. Can I do 100 in one? Yeah, this will be like 100 blocks is a lot of data, right? Null. Okay, this is probably too much. Good that we're testing. Let's do 10 at a time. Still null. 2 at a time? That works. Okay, maybe if I had a filter, this would work better. I mean, I could just, send all of it, but really I don't need all of the data. I could add myself a filter where, well, how is that payload? It should actually work the same as here, where payload is a block, right? No, the data, there are several blocks in the data, so I should be able to just one for one copy this part, except that it's not params data, it is payload data for each, and then in here we should get the blocks. And then for each block, if there's no error, we check all of the instructions, we check if it's a system program. And then instead of pushing it to the sender, let's do a const transactions to keep. We will push the entire transaction here. And then at the end of this loop with the block dot transactions is just the transactions to keep. Do you think that will work? Should we run a test? There we go. Then we just have, oh, because I said transaction, it's transactions. Transactions, there we go. There we go. And then for this first block, we get all the block height and block time and whatever. Parent slot, yeah, because we had this one. And the transactions is none. So we save some data. So let's save this. And if I have this filter, you think I can now do like 10 at a time? Fetch and filter? Or will that get me null again? That will get me null again. Why? Well, 5 blocks at a time. So the limit seems to be already before I can't get the payload even into that filter, I guess. Here, this works. But this is not doing the filtering. Is my filter not working? Oh, final payload. There we go. The filter is working. Okay. Okay, well, let's do 5 at a time. We could test if more works as well, but I get null here, so I'll just do this now. And my destination will be an existing function. My end is first function. I'll leave that. Then I would just say, well, first I run this one more. My return data, I called it 5 times, and all the senders currently is still an empty list. And if I create this, then it's delivering, it's streaming the old blocks onto my filter, which means if I now in parallel check this number should definitely go up. Yep, it is. It is going up. So my filter is definitely being called, and we're now backfilling all of the old blocks with this stream into my function. And once we get somewhat there, I think here was roughly my first transfer. So now I should already have in the sender, yep, my Blinko address. That's the address that sent me Sol. Cool. So the backfilling with this thing with the stream worked, and we're complete. So that stream is done. That stream has completed. Nice. And we just used it roughly 100 invocations. Yeah, because 500 and 5 each. So 100 times our function was called. You can probably batch it even more, like in bigger patches, but whatever. QuickNode takes care of the infrastructure anyway. And I'm still just running the free plan. So this is all just free. And now I can just, call this function, and I know which addresses have sent to my address in the past. Now for that to stay up to date though, so whenever I call it, it has all the up to date data, I will need another stream, or I could have used the same stream, that keeps streaming to my function. That, however, might get expensive if I, continuously do that. I say stream doesn't end. Oh, your stream has completed, so I need to create another stream. Fine, gotta do Andy's second stream again for Solana mainnet. We start at the latest block, we don't stop. Next. We can batch them in 5s. So if I don't use elastic, then it will wait until it has 5 to send the next 5, which for me is fine. If you wanted to have the most up-to-date, like if you want to be quick, then you want to use either elastic batch or say 1, but I'm fine with just having an update every 5 blocks. And I will use the same filter as before. And ideally, I would want to create a filter because I would love to be able to say, hey, only send there, only even have a payload if I ever had something to keep. So something like interesting block found. And then here I say interesting block found is true. If I don't have an interesting block found, then I would like to return nothing, basically. Don't even call the function. You think that would work? I'm gonna try this. Your filter did not return any data. If this is not expected, please check your function and stream settings. I mean, I would call it a success. I'm gonna save this. And then my question is still, will it call my function with this null as payload and then have the function fail? Or will it just be like, no, if that's null, we're not even calling the function. So let's see. Destination, I'm gonna put my same function. Let's see. And this one should be continuously streaming now. So this is delivering until infinity. So let's check if the number goes up. Yeah, it is going up. So it is even sending if... Wait, hold on. No, the number is going up because I call it. The stream has null. It doesn't invoke the function. Nice. The payload is null. It's not invoking. So what happens if now... Wait, I need to send from a different address. Use the NDC. So we're at 115 and only the Blinko sent there. And then I say Solana transfer 0.001 sol again. It doesn't matter, just something to the guy that we're checking for. So to this ND receiver. I always get it wrong. It's the other way around. It's first the receiver and then the amount. There we go. And now if we call the function again, cross your fingers. Damn it. It looks like this stuff is not working. Oh, because it terminated. No, why did it terminate? Start it again. It's now active. I'm gonna just send another 0.01 sol. Check. Is it dying because I'm trying to send something and it doesn't? Maybe it doesn't like that I return null here. Error sending data to function. Cannot read property of undefined reading dataset. That's why it's stopping. Okay. So it probably doesn't like my filter. You know what if I don't do that? One last try. And is third stream. Do we even want a filter? Yeah, I mean, I kinda, while we have it. And my destination will once again be my function. Okay, so, and with this thing streaming, let's see if it counts up the calls. Yeah, now it's bumping all the data in there. Yeah, it's quickly going up. So if I now transfer there, then no, still not. But is it still counting up or did the stream die? Nope, still. Oh, here it is. It just took a while. Maybe I was too fast or something. Now it is here. Look at that. And the stream is still going. The stream is still streaming in the data. And I have the newest sender in here as well at all my senders. And that's really the thing that I'm interested in. Cool. And not to burn all of my credits, I'm gonna pause this stream again. But yeah, that's pretty cool. We can just stream all of the blocks onto my function. And my function will do stuff with it. It will do its logic, store stuff in the key value store. And then when I query it as a user, it will also return me the data that I'm interested in. And then I'll have all the people who sent me sol in a neat little list with my function. That's cool. And that, ladies and gentlemen, is QuickNode functions and key value store and streams for you. Ow! I hope that you got an idea of what QuickNode functions are, how to use them, also how to use them in combination with streams and the key value store, which all of those things together is quite a powerful infrastructure that you have available. And if you're just developing a little bit, you can do all of that in the free plan as well. That's quite cool. If you need more resources, of course, you might want to choose a paid plan by QuickNode. In this example, I just had the free plan and that was fine. So yeah, I hope that you learned something and I'm looking forward to playing around with this a bit more in a future video. Till then, bye bye. And you can watch other non-QuickNode sponsored videos here. Like this video if you want to, subscribe if you feel like it, and I will keep bringing you nice Solana content that might or might not be sponsored by QuickNode.